Welcome guys. In the previous part we have discussed how to calculate work done when we have a constant force. Now in this part we're going to apply this concept and we'll find it out how we can apply in calculating work done when we have a gravity and friction. So this is what we have to see. Let's have a look. So work done by gravity and friction. So let's see first what is the work done by gravity. So this is the figure given to us, that this shows that block is coming downward from the inclined plane, and h naught is the initial height of the block and hf is the final height of the block, where this shows this is the distance between h naught and this is the difference between the height. This h is the difference between the height, and the displacement given to us along the inclination is s. So what do we know about the work done? Work done is equals to F vector dot S vector. That means what we can write this as F vector mod S vector mod cos, and the angle between the force vector and the displacement vector, which is given to us as theta according to the figure. So therefore what we can write, we can write this as, since we have to find out the work done by gravity, so what we can write this, F is equals to mg. So therefore let's substitute what we're going to get. This we're going to get work done by gravity is equals to mg into s cos theta, like this, mg s cos theta, work done by gravity. Now if we look at the figure, this is figure given to us, that this is the height h and this is the displacement s and this is angle theta. So what we can say, if we'll find it out the cos theta, so guys what we're going to get this as h by s. Therefore we'll get h is equals to s cos theta. Now if we'll substitute the value of s, that, or else we can write this as s by h cos theta. So if we'll substitute the value of s, so what we're going to get? We're going to get this. So thereafter what we're going to get, work done by gravity is equals to mgh. Therefore with h is equals to h naught minus hf. This is given to us as given to us in the figure. So therefore what we can say, that the work done by gravity is independent of path taken between h naught and hf. Yes, that is true, because what we are getting is this h, or precisely if we write down this, what we are getting, mg h naught minus hf. This is what we are getting. That means it depends upon the initial position of the block and the final position of the block. So therefore the gravitational force is a conservative force. So this is given. So we'll talk about this thing, what exactly is the conservative force. We'll talk about this later. Since at this moment gravitational force is a conservative force because it depends upon the initial and the final position. Now let's find it out, what is the work done by the friction. So when a block is pulled by a force F on the stationary surface, so as we know that this is the situation, something like this. This is the ground and this is the block, and which is moving in this direction. Now as we know that the friction depends upon the relative motion between the two surfaces. Now the relative motion between the two surfaces, if we say that the force F is in this direction and body is moving in this direction, this is the force acting, so automatically the relative motion between the ground and the block is along this direction. If we talk about this, let's say this is y axis and this is x axis, so what we can say, that block is relative motion of the block with respect to ground is along x direction. So friction will be going to act in the negative x direction. Here we'll have the friction. Now if we'll talk about the other case, that the block or the force is acting along minus x direction, so displacement of the body will be along minus x direction, so force of friction will go along positive x direction. So therefore since relative motion has changed, so the force of friction has changed its direction. So therefore, kinetic work done by the kinetic friction is negative. That is true because if we'll talk about any case, if we'll say that the displacement is along this direction and force of friction, so therefore force of friction will comes out along this direction. So cos this angle between the two will comes out to be 180. So cos 180 will be minus 1. So therefore the work done by kinetic friction will comes out to be negative. Now if we'll talk about the, as we have done in previously, as we have done that the nature of the work can be positive, negative or 0. Let's talk about when it is 0. It is 0 when block does not move. For this case, let's say we are applying force and block does not move. So in that case we can say that the work done by the friction will be 0. So this is the case. This is the second case. Now the third case is that, can a work done by the friction on a body be positive? The answer for this thing is yes. How it is so? Now if this is the situation given to us, if we will talk about this situation, now this is the force which we are applying on block B. So therefore what we can say, if we make the free body diagram, or if you want to find it out what exactly the force of friction, or what exactly will be the direction of force of friction, let's check it out. If we say that this is the block is pulled by force F, let's say, and this is block B. Now if we place an observer over here, so the person which will going to say that the block A, according to this person, block A will have the tendency to move in the backward direction. So what we can say, that the relative motion between the block B and block A, or what we can say, that the relative motion of block A with respect to B is in the backward direction. So therefore what we have done, that the force of friction depends upon the relative motion. So therefore the block A has the relative motion in this direction with respect to B. So what we can say, that the force of friction will going to act in this direction. Now if body, so therefore if we'll talk about this as the complete system, because as force of friction is there, or the surface is rough between the block A and block B, and they'll move together, they'll move and they won't lose contact between. So therefore if we say that this is the complete system, so what we'll say, that let's say the system is making a displacement S. So for block A, force of friction is along positive x direction and displacement is also along positive x direction. So therefore what we will get, work done will comes out to be positive. So therefore this is the case where force of friction causes the motion, not opposes the motion. So for this case, force of work done by the friction can be positive. Now let's look at the example, that find the ratio of the work done by the block under two condition. Okay, the condition is something like this is something like this. This is H and this is alpha, and the displacement is given to us as S1, and the other second condition is something like this. This is making an angle beta, or this is beta, and displacement along the inclination is S2. Since height is same for both the conditions, so what we have to find it out, we have to find out the ratio of work done by the gravity, and block has to come from this position, let's say A to B and C to D. So therefore if we'll say that the work done coming from A to B is W1, and so we have seen that it depends upon the initial and the final position. So what we are going to get, that this work done will comes out to be mgh. For the second case, similarly for the second case, work done by coming out from C to D will be mgh. So therefore, if you want to find it out the ratio of the two, the ratio will comes out to be 1 by 1. So therefore, option C should be correct for this. Now let's look at the next example, that work done by the friction on 15 kg object, mass is given to us as 15 kgs, okay. Now we have to find it out, the object pulled horizontally in the straight line for 15 meters, displacement is also given to us as 15 meters, and if the coefficient of friction between the object and the surface is mu k, since its kinetic friction is given to us, that means block is moving. So therefore what we can say, that this is somewhat the situation, that force is acting in this direction. Let's say this is the force acting in this direction and block is moving in this direction, and force of friction mu k is there between the ground and the block. Mu k is equals to 0.4. So therefore what we can say, if we'll make the free body diagram of this block, what we're going to get, we're going to get this normal which will act in this direction, and mg, the weight force, which will going to act in the downward direction, and since body is moving in the plus x direction, so force of friction will going to act in this direction, and this is the force which we are applying. So therefore we have to find out the work done by the friction. So therefore what we can write, work done by the friction is equals to F, that is, this is the force of friction, S, that is the displacement, cos, okay, cos, it will be cos 180 because displacement is along plus x direction and force of friction is along minus x direction. So this is making an angle 180 with each other. So this will comes out to be minus Fs. Since we have to find out, first let's find it out what will be force of friction. Force of friction, since body is in motion, so force of friction will be equals to mu k into n. So therefore what we can write, mu k, n will be equals to mg. Since body does not, since the body is not moving along, or there is no motion along the y direction, so normal will comes out to be equals to mg. So mu k, so what we can write, mu k mg. Now let's find it out. This will comes out as 0.4 into 15 into 9.8. This will comes out to be nearly equals to 59 newtons. This is 59 newtons. So work done will be equals to minus 59 into 15. So this will comes out to be nearly equals to, this will comes out to be 885 joules. So this is nearly equals to 890 joules, minus 890 joules. So option E should be correct for this. So guys, in this part we have seen that how to find out the work done by the gravity and friction, and also we have learned that work done by the friction can be positive. That is the important thing which was there in this part. And now let's move to the next part and let's see what we have in the next part.